I taught a bottom set at Cranbrook School last year, bottom set year 10, and I tried a few activities out, and it was a wonderful opportunity actually teaching a bottom set, because they were the no maths students who were going to give up. And so there really weren't many expectations. I didn't have to keep up with a particular cohort or a scheme of work or whatever. And in fact, I went completely off piste, because it's not that no one cared what I was doing, but I wasn't really that accountable. So that's ideal teaching as far as I'm concerned, just completely blank sheet. And it gives you a chance to create and re-engage. And my focus for that year was to, these kids had been kind of mathematically abused for like years and years. Every time they'd done any maths, they'd failed. And I just wanted to give them some sense of success, some sense of confidence, and see whether I could build that. So anyway, this is the kind of student that these guys were. How I see math word problems: if you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. So I quite like that. So anyway, it was a breath of fresh air. I'm going to show you what happened. So the first 5 weeks, we basically, I offered them, I said, look, we can do consumer arithmetic, and that's something which is really useful, and it will be really useful for you and your future. You can actually use this. Or we can learn how to count in ancient Mayan. And then we can learn how to count in a completely random number base, and you can learn some really, really abstract maths which even the 4-unit students in year 12 don't get taught. What would you prefer? So what do you reckon they chose? They chose the abstract maths. That was what was engaging for them. They weren't interested in a utilitarian approach. That wasn't of interest, which I think is quite pertinent, because a lot of maths syllabus writers and a lot of influential maths educators feel that we justify our profession by making it useful, and that's the only way to engage students. It isn't. Here's the end of the 5 weeks. This is Hugo and Hugh's presentation. Oh, no, it isn't. Is that? Maybe I have to click on it. There we go. So this was their assessment in front of VIPs, including heads of various. You and Hugo are to yes, 12.
Right, well, we've been working on base 12 this term so far, and I'm Hugo, this is Hugh. Here we have what base 10 looks like, and here's what base 12 looks like, so I'll take a simple number, just 1. In base 10, this is 1 in the 10,000s column, 1 in the 1,000s column, 1 in the 100, 1 in the 1 in the 1s, and we say this as 11,111. But in base 10, this is 1 20,736, 1 1,728, 1 144, 1 12, and 1 1, and you'd add them all together to get 22,621, and yeah, that's that. Okay, how base 12 works. In base 12, there are 12 symbols. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, until A and B, which are 2 new symbols. The reason there is A and B is because we have to run out of symbols, because we already have used 1 and 0. 1 and 0 would be 12 in base 12, and 1, 12, and 0 units. While in base 10 it would be 1, 10, and 0 units. Example, 100 in base 12 is 8, 4, because there are 8 12s and 4 units.
That's good. You said there's 12 symbols in base 12. How many symbols are there in base 10?
10.
What are they?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good.
Oh yeah,
Cool.
You're asking all the tricky mathematical questions.
Okay, any more questions for Hugo and Hugh? I've got one. Are there any advantages of using
using base 12 rather than base 10?
Well, yeah, because it has many more like factors. There's a lot more goes into 12 than any other number. So that's
So why do we count base 10?
if you have 10 fingers, I guess that's.
Is that the only reason?
Oh, it's probably not the only reason, but
Yeah.
it's for a pretty simple reason.
What does the word digit mean?
Finger.
Finger. Cool. Thank you very much. Okay, next up.
So I'm not sure how much of that you could hear, but that was pretty unbelievable. These are kids who have failed every maths exam. They've sat their bottom sets. They're about to go on and do no maths. They're not apparently motivated to do anything in year 10. They're just in the classroom, and yet after 5 weeks, you can see, even though that's not on the syllabus, it ticks so many boxes in terms of place position and exponentiation and what was he talking about at the end? He was talking about factors. I mean, it's really quite amazing how all of that maths comes out of this project. The other thing is, I think that as maths teachers, we sometimes are so obsessed with getting through the syllabus. I haven't got time for it. I've got to get through the syllabus. I've got to get through the syllabus. We haven't got time. We've got to test them. And it sort of goes on. And in the end, the whole point of the syllabus is they're written so that they're written in a way to try and encourage maths teachers to teach conceptually. And yet, paradoxically, they end up, you get a textbook which tries to follow the syllabus, and then maths teachers try to follow the textbook, and then they feel obliged to do every single exercise in the textbook, and they set homework because they can't get through it, and then you've got little year 7s who get smashed in their first year with all this homework. And it's not education, is it? I mean, that's really not what we're trying to... Well, it's not what education should be about. So I think we sometimes need to take a step back and be confident to go off-piste, knowing that we can still teach the same concepts and actually probably more effectively and quicker. So by the end of this project, it filled them with a sense of self-esteem that they could actually talk about number bases, and they understood different number bases in a way that other students in the school didn't, and it was really quite highbrow maths, and that really picked them up. We put it on the portal so that everyone could see their presentations. It was really quite a nice little project. And there it is again. Comes from this guy. Well, it doesn't, but those of you who are my era remember doing number bases in primary school with these things called Dean's blocks, after Zoltan Deans, who actually died this year at the ripe old age of 79. I'll just read you his obituary. Referred to as a maverick mathematician, Zoltan, another Hungarian by the way, introduced revolutionary ideas of learning complex mathematical concepts in fun ways such as games and dance, so that children were often unaware they were learning mathematics. They were having a wonderful, exciting, creative time and longing for more. He invented the Dean's multi-base arithmetic blocks and many other games and materials that embodied mathematical concepts. What's nice about this, and I remember learning it, it's not just place position, it's also links in with visual learners and volume and surface area and dimensions. It's actually brilliant. It's such a shame it's gone out of syllabuses as such, but you can still teach it.